Let's get that tryptophan. Let's let it kick in. How's everybody doing? You guys ready for another amazing speaker? Yeah. All right, let's do it. Thanks for all your hugs and sweet words during lunch. That was, hey, come on, I love you. Yeah. Our next speaker is co-founder and chief technology officer at Boom Supersonic, the aircraft company working to restore the glamour of supersonic air travel and make commercial high-speed transportation both a reality and just darn cool. His role sits at the intersection of engineering, design, and marketing, which all lead to reimagining the airline's in-flight experience and crafting the company's brand. He's built software for a wide range of applications, including computer graphics and physics simulation, a joint BS and BFA degree holder in computer science and design from Carnegie Mellon University, and also an MBA MPP from Chicago Booth. He promises to restore your hope in flying and bring excitement back to the big blue skies. Let's give a warm welcome to Mr. Joshua Krall.
Okay, thanks, John. Really happy to be here today. I hope everybody had a good lunch and try to keep you awake. I wanted to start today by talking about sort of how we experience the planet. How do we want to spend the precious time we have here, and why do we choose to travel at all? Why is travel important? Now, perhaps it's to do something like experience live music at a fantastic venue like Red Rocks. This is right outside my home base in Denver, Colorado. Or go after world-famous culture like you might find at the Vienna Opera House. Or maybe you want to kind of get off the beaten path a bit and learn about history, see the sights of Machu Picchu. And we had an amazing presentation earlier about virtual reality, and today we have this amazing hardware that can be incredibly immersive and allow you to step into whole new environments, real or imaginary. So you have to ask yourself, could we just do this instead of traveling at all, right? And this is probably familiar to everybody. You can jump on a video call these days with family and friends, even if they happen to be halfway across the country or on another continent. But of course, if you really want to experience everything the planet has to offer, you need to go for real. The Grand Canyon in Google Earth VR is really amazing, actually, but it pales in comparison to the real thing. And taking a trip with someone you love adds an entirely new level of meaning. And it's these kinds of memories that we carry with us through our lives. In our business life, we all use video conferencing and email and Slack to kind of work with remote colleagues. I'm sure you do tons of that, and we do as well. But the really important deals are done in person. And the most successful work, the most creative work, it's done face-to-face in the same room. You need to be able to look at the other person's eyes and see what's going on behind their eyes. Now, the good news is that we're living in an age where there's frequent, reliable, and safe access to every corner of the planet. Here's a map of all global air traffic routes today. If you look at global passenger volume since 1970, there's been healthy growth for the past 5 decades, with almost 3.5 billion passengers in 2015. So modern communication hasn't reduced our demand for travel at all. It's quite the opposite. The more ability you have to form remote relationships, the more likely you are to visit in person. Technology gives us a taste of what the world has to offer, but it only makes our appetite stronger for the real thing. And airlines today offer some amazing onboard experiences, especially if you're lucky to be one of the few who fly in the front of the airplane. If you are that fortunate, even if you are that fortunate, the reality of travel today is we spend a great deal of time like this. So if we zoom all the way out and we sort of look at throughout human history, there's been this steady march of progress in our capability of accessing the planet. At each stage of technology development, our horizons expanded and new possibilities opened for business, romance, exploration, adventure. In a Boom, we spend a lot of time thinking about that top right corner. What belongs up there? What's the next evolution in travel and human capability? So one answer to that was Concorde. Many of you are probably familiar with this airplane. It was a brilliant feat of engineering, designed in the 60s, first flight in 1969, retired in October 2003. Mach 2 cruising speed is capable of taking 100 passengers across the Atlantic in about 3.5 hours. But only 14 flew commercially. So what happened? It's worth stepping back in history briefly to explain this story. And one way to do that is to look sort of through a lens of Hawaii as an interesting case study in aviation history. So if you wanted to go from San Francisco to Hawaii in the late 30s and 40s, you'd take one of these flying boats. And it took about 18 hours. So only a few thousand people ever made that trip. And the jet age changed all that. The Boeing 707 Clipper was the first commercially successful jet airliner. It was introduced in 1957. And suddenly places like Hawaii became tourist attractions, and travel to the islands increased 6x over the next decade. And it's continued to go up since. And the dawn of the jet age had a broad and sometimes unexpected impact on the world at the time. Before the jet airliner, baseball was confined to the eastern United States because travel to western cities was impractical for the schedules they needed to have. And the Beatles made the first world tour in 1964. Not a coincidence. The jet airliner made the world tour possible. So in the 60s, the Concorde was imagined as the natural next step in aviation. Just as the jet airplane replaced the propeller airplane, Concorde was going to bring supersonic travel to the masses. Many people have heard of the crash of the Air France Concorde in 2000 and assumed that this is what sealed the airplane's fate. But the reality is that Concorde was an economic failure, not a technical one. Concorde was not a very fuel-efficient airplane. And part of this was due to the fundamentals of supersonic aerodynamics. It requires more thrust to go higher speeds, and more thrust requires more fuel. But this was an airplane several decades ahead of its time. In the years since, there have been many advances in airplane design and manufacturing that the Concorde designers were not able to take advantage of. So more on that in a bit. Here's what the cabin of Concorde looked like. It wasn't very spacious. 100 seats that were rather small and uncomfortable. The windows were about the size of your iPhone. If you ever get the chance to visit one at an air museum, I recommend it. They have one in Seattle and in New York and in DC. It's a beautiful airplane. But despite the small cabin, it was really the ultimate in luxury travel at the time. Famous, favorite of celebrities. The food service, champagne, amenities on board were the very best. One of these seats from New York to London would cost about $20,000 round trip in today's dollars. And that price, many of these seats flew empty. Now, this was the 1960s, and we had the Apollo program going on, and there was tremendous pride in US aerospace. So it really wasn't acceptable for there to be a supersonic airplane coming from France and the UK with no response from American industry. So this is one of the designs for the Boeing 2707. It was a largely government-funded airplane design. It was supposed to be our response to Concorde. It had a 250 to 300 seats, and it was intended to go Mach 3. Clearly not a project designed around an economic goal. This was a prestige project. And in 1971, Congress sort of figured that out. They gave up on the project, pulled the funding, and simultaneously they passed an overland ban on supersonic flight in the US. This was the final nail in the coffin for Concorde. It needed the overland markets to be a viable product for the airlines. So how do we break through on speed? If Concorde wasn't successful, what can we do differently today that can be the next step change in travel? So this is the Boom Supersonic airliner. It's designed to carry 55 passengers at Mach 2.2, or 1,451 miles per hour. That's about 2.6 times faster than today's subsonic airplanes. I'd like to talk a little bit about the engineering that goes into this airplane and why it's possible to do it now, and the key differences between our airplane and Concorde. The three main areas of innovation in aerospace that make this possible today: aerodynamics, materials, and propulsion. I'll briefly touch on each. So here's what engineering looked like in the 1950s. Can anyone spot the major difference between how things are done today? I'll give you a hint. Our engineers don't wear neckties. So that's the start. I mean, seriously, the Concorde designers worked in wind tunnels, and they built models like this, each one taking about 6 months to design and build and test. So they only got to do about several dozen iterations of their design. And today we have the advantage of sitting on 50 years of aerodynamics research, and more importantly, computing and software. So instead of 6 months between design iterations, we run hundreds of designs per day using virtual wind tunnels and computational fluid dynamics software. Aerodynamics is one of the most challenging aspects of a supersonic airplane to get right. The wing designs tend to be what are called swept delta wings, this sort of triangle-shaped wing that you see here, and Concorde as well. It has to do with optimizing a shape that will tuck behind the shockwave cone that's created at supersonic speeds. And being able to iterate on these aerodynamics and refine that wing design is a major enabling technology that we rely on. The next one is carbon fiber composites. Most people have heard of carbon fiber composites. They're used in a lot of different industries, but they've only recently become widely available for use in an airliner application. Many parts of the Boeing Dreamliner 787 are carbon fiber, and they've paved the pathway through the FAA of how to use carbon fiber in a certified environment. To make a carbon fiber part, you either CNC or 3D print a mold like this, and then you lay layers of carbon fiber in the mold with a special resin or glue that you cure in a computer-controlled oven. And carbon allows us to build the streamlined, flowing shapes that the aerodynamicists require without worrying about spending hundreds of $millions on aluminum tool stamping that would have to, custom tools for each part of the airplane. And the other thing about carbon is they handle the extreme temperatures of supersonic flight much better than aluminum. So Concorde famously grew about a foot during cruise because the aluminum would expand. And our airplane will have to deal with minimal thermal expansion because the CTEs of carbon fiber are relatively low. And lastly, we need to talk about engine technologies. Concorde was the only airliner ever to fly with an afterburner. We recently had a Concorde engineer come to our headquarters, and he talked about when they turned on the afterburner, there was a 78% increase in fuel use for only 17% more thrust. It's a terrible way to get more thrust. In addition, the Olympus engine, which was what powered the Concorde, was a turbojet. And 50 years later, we now have what's called a modern turbofan. This is what you see on all major airliners today. There's this large fan in the front. It's driven by the turbine, and it does the first stage of compression. And importantly, a large amount of the air that enters the fan goes around the hot section of the engine in what's called a bypass duct. This allows for more air to be accelerated less, which is a key recipe for quieter, more fuel-efficient engines. So our engine will be what's called a medium bypass turbofan, similar to what's on the 787 today, but a smaller package that's optimized for a trade between airport noise and supersonic drag. So with these major developments and a whole bunch more, it's possible to get 30% more fuel efficient than Concorde. And if you combine the fuel efficiency of our airplane with the fact that it's sized for overwater routes today, this allows you to create a product that airplanes can fly in over 500 routes worldwide versus just the single route, the New York to London route that Concorde made money on. So there she is, but what would it be like to fly on a modern supersonic airliner? Could we reimagine anything else about the interior? Even when we have similar space constraints that the Concorde had, a smaller cabin. So our designers have been working on how we could rethink business class seating to fit our unique cabin in our airplane. On most routes, you get there so fast, you don't need a lay flat bed anymore. You just need a comfortable first class style seat. So that's what we're aiming for. You need a comfortable environment where you can be productive, relax, watch a movie. Each seat is both an aisle and a window, and you have a dedicated overhead bin. On the longer Pacific route, some of our airline customers have asked for two-class cabins, and so we've been looking at how a lay-flat bed might fit into the experience. These are all very early stage, but we wanted to show the airlines what's possible. And as we continue to talk to them, we sort of have a strong desire at Boom to influence even more aspects of the airline product experience. From baggage handling to check-in, food service, every customer touch point matters. And the worst thing we could do is improve the speed and get you there so much faster, but you then spend almost as long in the airport and dealing with frustrating airport experiences. So this is where we're starting. It's the simplest, economically viable supersonic airplane that we can bring to market. In lean startup terms, it's our minimally viable supersonic airplane. So to really understand what this airplane is capable of, I have a few example itineraries. The first one really drives home the kinds of trips that become possible when you can travel more than 2 times faster. So if you could take the first flight out of New York, you can be in downtown London by early afternoon, spend the afternoon in meetings, have dinner with a client, and then catch the last flight back home, and you're home in time to tuck your kids into bed on the day you left. Now, that's not a trip everybody's going to do, but it's a trip that's literally impossible today. For San Francisco to Tokyo in just 5.5 hours, so this cuts entire days off a trip to Japan. Instead of sleeping on the airplane, you sleep in a comfortable hotel bed. Or better yet, you sleep back at your own home with less time away from your loved ones. And lastly, LA to Sydney is fascinating. Sydney today is about as far away as Hawaii was before the dawn of the jet age. So as a result, many people can't afford the time and money to make a trip to Sydney. Imagine the change in tourism and business relationships if we could get there in under 7 hours. So I hope I've painted a picture for you of a future that is within our grasp. At Boom, our vision is much bigger than the first airplane. We're on a decades-long mission to make the entire planet more accessible, not just for the business elite, but for everybody. And when you create a fundamental step change in the speed of travel, you change the world. We made a short video that kind of conveys what this mission means to us, and I'd like to play it for you.
The pursuit of speed is often relegated to the adrenaline seekers, the risk takers, the record breakers. But our pursuit of speed is about something greater. It's speed in service of the experiences that make life precious. Imagine, if you will, flying across the Atlantic, doing business, and being home in time to tuck your children into bed, or where New Zealand becomes as accessible as New York. What would that do for families, for culture, for business? The technology for supersonic flight has existed for over 50 years.
This is the new supersonic airline.
But it was too expensive for routine travel. At Boom, we are refining it, perfecting it, so that high-speed travel can be available to anyone. In the digital age, there really is no more distance. There is only time from one another. Our mission is to remove that barrier, meaning more meetings in a day and more nights with loved ones. Where children grow up with their parents at home, and where relationships are no longer considered long distance. We see New York to London in 3 hours instead of 7. San Francisco to Tokyo in 5 hours instead of 11. We see world leaders spending more time in the same room, the acceptance of cultures, and the spreading of ideas. At Boom, we see the time saved as really the least important part. This isn't about time saved, it's about life gained. Together, we can make cities into neighborhoods and make the world a smaller place. Boom. The future is supersonic.
So I want to thank everyone at Salesforce for inviting me here and letting me share this vision with you. We have an amazing team in Denver that's working on this problem, and happy to answer any questions.
Thanks, Josh.
Mm-hmm. Sure.
Terrific. The first question I have: how fast can you get me through security when this all goes all goes down?
It's no joke, actually, right? Like if you make the flights half as long, you then have to deal with some of these other problems, and it's something we spend a lot of time thinking about, actually. Early on in the company's history, we wanted to also do an airline, and we decided one hard problem at a time. But
when you first heard about this, where were you? What were you doing? How did they get
oh
on
boy,
board on this project?
yeah. So our CEO Blake is sort of the visionary behind this. It's his idea. He's been dreaming of it for more than a decade. And we worked together at a previous company. We were at Groupon doing some software stuff, and
Groupon, supersonic jets. Makes
yeah, you'd
perfect
think,
sense.
right?
Yeah.
I mean, not to knock too hard on Groupon, but I will say there's nothing like working on coupons that makes you want to do something a little different. So, No, I mean Groupon is good to me, so I don't want to hit them too hard. But
Okay.
But I mean, no. You know, we both came from startup world. We've done a handful of startups. I've kind of worked in a lot of different domains, as you know. And when he left I think a year or 9 months before I did, and I kept going to lunch with him and finding out about all the things he was working on, I just had to figure out how to get involved. It's too cool.
That's great.
So.
I was surprised by your presentation in that it wasn't so much about the technicality of it all, that it was more about family for some reason. And I mean, there's a huge thread in my life, and what I like to push through the team is that family first, get home, make your home life as important as you can, be great at home, and then you can be great at work.
Yeah.
But your whole theme is kind of like this family first theme. Tell me about that. Is that something that comes from your heart, your soul, or is that a marketing
No,
thing?
it definitely runs through the DNA of the company for sure. I mean, I think you know, there's been a number of supersonic airplane projects, and they usually come about first in the form of a business jet that is sort of for a, you know, as we like to say, a rich billionaire who's going to fly around the world. And there's a place for that, sure, but I think our DNA is much more about making travel faster for everyone and making the world smaller and more accessible. You know, history shows us that has all kinds of far-reaching positive impacts on the world, and I think it's something we're inspired by as a company, for sure. Certainly our engineers are. I mean, we're mostly an engineering company at this stage, but so there's not a lot of marketing, you know, team that's put a lot of effort into this kind of thing. It's more like part of who we are.
Yeah.
Yeah.
What's the goal? When's this coming? When are we going to get on it?
Right. Yeah. No, that's a good question. So I didn't talk too much about, you know, our roadmap, but what we're doing right now is actually building a smaller airplane, a demonstrator airplane, what we call the XB-1 technology demonstrator, and it's about the size of a fighter jet. It has 2 seats. It's not a airplane for anyone to fly. It's literally just test pilots. It's experimental airplane. But it will prove many of the key technologies, the inlet design, materials, propulsion, a lot of the hard problems that we know we have to go solve for a full-scale airliner. And we intend to fly that next year. We have a team of about 25, and it'll be 50 by end of the year, working on that right now. And once we fly that, then the next step after that is to go to the full scale. But you know, one thing at a time. We're a startup, so.
Yeah. When you're in the middle of a problem at work, and do you guys probably don't say, "Hey, this isn't rocket science"? 'Cause it is. What do you guys say? Like,
well, it's funny because we actually do say that, but we have a number of rocket scientists on the team.
You do?
And yeah. One of our program managers actually came from SpaceX and owned the second stage of the Falcon 9. So I don't know what they say at SpaceX, but we can't help but to use that phrase. It's too common.
You're making it kind of beautiful, though. It's not like all technicality. There's like a lot of beauty in what you're trying to put together.
Yeah.
What's the spirit, the culture inside?
Yeah, I mean, I
what
think
is it? Anything's possible? Or?
It's definitely anything's possible. We have a start. We actually say we sort of have a start with yes culture inside the company. You have to. I think potentially you need to be even a bit naive to start a company like this, and then not too naive that you make stupid decisions, but you have to be a bit of a dreamer, and I think that's the kind of people we have. We also have people who are incredibly passionate about aerospace and about airplanes. Our offices are in a hangar overlooking the tarmac at Centennial Airport, which is southeast corner of Denver. And there's airplanes going by all the time. And one of the things we joke about is that when we're interviewing candidates, if they're not distracted by the airplanes going by, there's probably a culture fit issue, because they need to be airplane nuts. So, yeah.
What have you brought with you through every job that is now existing there? What have you learned? What are the sparks?
Oh man, that's a tough question. Well, I'm a very cross-disciplinary type person. So I'm a software engineer by training, and most of my experience is in software. But in every role I've had, there's been a bit of creative in there, a bit of company building, marketing, sales, and I kind of love that. So I guess that's my through line through all the way to Boom. People ask me, how did you get involved with this? I can't really explain how, other than I decided to jump on board and do it. So
That's great. We've got a lot of people that work in the discipline of user experience in here, and
Yeah.
that's, I mean, that is a huge part of who we are as a company, getting that feedback, listening. Before you can even take a flight like this, how do you bring that discipline
yeah.
into the company before anybody can actually experience this?
Yeah, absolutely. So, I mean, I think there's a couple ways to take that. User experience, we have to deal with it a little bit now because we're trying to paint a picture for what the future could look like to airlines. And we're out talking to airlines now and trying to sell airplanes to them and getting their feedback about what matters. And, so we've done some interior designs of cabins, for instance, even though ultimately they will have the biggest influence over that. But you have to paint a picture in their mind. And that sometimes includes things like what can you change about the customer experience walking on the airplane, how the in-flight entertainment could work, things like that are kind of in the weeds, but the more of the future you can make seem real, the easier it is to imagine. So I think that's a piece of it. I can't remember the rest. Yeah.
Neither can I. I'm making this stuff up as we go along.
Yeah.
I have no idea what I'm talking about, especially when it comes to rockets.
Cool. You and me both.
There, yeah, great, fantastic. We're in an environment now. We got SpaceX. You got all these billionaires building rockets, want to go to
Yeah.
space. You've got, oh my God, why can't I think of his name? The Virgin guy,
Yeah, Richard Branson.
Richard Branson, who I've interviewed, and I can't remember his name. Thank you very much. I've been off for a long time, but that world.
Yeah.
That world is just happening now, but it's also, nobody knows when that button's pushed. I mean, everyone's just crossing their fingers,
Yeah.
right? And so a lot of these things don't make it back. I mean, no one's on them yet, but they're exploding and they're learning. And how do you come to work knowing that first thing you might send up is
Right.
going to explode? Like, is that with a bunch of engineers knowing that, hey, this thing might just blow up? We might kill
That's it.
everybody that we send off on the inaugural flight.
That's a good question. I mean, I think the people at SpaceX probably feel that most acutely, or
Yeah.
Blue Origin or any of the rocket companies. I mean, the reality is an airplane. The development process for an airplane is actually remarkably different. I mean,
Right.
with the rocket, you basically have to do the full thing the first time. There's no, well, let's just fly a little bit, and well, now they can come back down, but that's fairly new. With an airplane, first of all, the FAA has a very specific and strict process for how an airplane comes into market and what tests it has to go through, and there's a many years long certification process to make something safe. We have our issues with that process, but the truth is that it does result in safe airplanes that we all get to fly on all the time and very rarely have problems. And part of the way you do that from an engineering standpoint is you have something called envelope expansion. So when you have a new airplane, the first thing you do is just leave the runway and come back down, or you even do a taxi test. And then, so very slowly you increase the parts of the airplane's flight regime that you're going to test, and you're just pushing the envelope is where that phrase comes from. You're pushing the envelope at each flight test just a little bit, and so the risk you take on at every moment is small, and that allows you to kind of safely get all the way up to the full envelope of what the airplane's designed to do. So that's a long way of saying there's a process for this. Again, I'm not an aerospace engineer, but I work with many of them, and this is what they do. So,
what's it like working with people that are they very rigid mathematical based? Are they all about structure, or are they wildly creative as well?
I think
how do you find them?
It's a little bit of both. I mean, they're definitely some of the smartest engineers I've ever met or worked with. Very challenging problems we have to solve, but there's creativity in all kinds of work, and I mean, I can relate to that as a software guy. I mean, I've written code and felt like it was a creative endeavor. I think they would describe it the same way. That said, they're different creative types than I would say most people here probably. They're definitely aerospace geeks. That's what they do.
So, like, are you writing code now there? What are you doing?
Maybe about 10 to 20% of my time. I write some software, all different kinds. I do marketing stuff. I do a little bit of design occasionally, but hopefully not too much.
What's your favorite thing to do of all the hats you're wearing right now?
Oh, gosh, I don't know. I think it's more on the company building and sort of, startup side of things, we're at an interesting stage as a company where we've grown from, let's call it 10 to 25 in 9 months, and we have to double in size again over about the same time. Trying to do that right and keep the culture the same and keep it the right kind of company, really challenging. I've never done this kind of a growth curve before, so it's really an interesting problem for me. I think that's where I find the most sort of creative energy at the moment. But
What kind of people do you look for?
oh boy, people who have a curiosity for the world and they kind of express it. We talk about it on our team as sort of a builder mentality. And sometimes it's very practically a builder. Like in their garage, we have people who've built their own CNC routers and people who weld and work on cars and basically hack on hardware all the time. That's a definite sort of type that we like. But what it really is expressing a curiosity about the world. They want to understand how something works, and they want to just go build it and tinker with it to get that understanding. So not everybody is actually a mechanic in their garage, but they have their own version of that, their curiosity about something they explore in their free time. And I think that's one of the main kind of cultural tenets that we really care a lot about.
How does the company, how does the vibe feel? How do you deal with failure, hitting brick walls? What goes on there?
Yeah. So we have, failure, I mean, you have to create an environment where failure is acceptable, where people make mistakes and they own them and then they just
And that's the
fix
cliche,
them.
but some
Yeah.
places it's not really true.
No, I mean, it's a challenge for sure. I mean, one of the silly things we do, but sometimes the silly things matter. We have these two things in the office. One's the blade, one's the nut. The blade is a stator blade from the Concorde, actually, that is signed by a Concorde engineer. And you get awarded the blade for doing really exceptional work on some project, any kind. And it gets just passed around the team. And then the nut is it's literally just a nut on a rope. and you have to take the nut if you make a mistake or do something, and you just own it to the team. You say, hey, I screwed up something today. I'm taking the nut. And it's a funny cultural norm. You do it publicly in a group setting. No one is going to knock you for the mistake, and it teaches a culture of sort of an openness about failure. And it doesn't matter as long as you learn from it.
That's awesome.
Yeah.
We got to start that. Take the nut.
There you go.
Yeah, I like that. I don't know. I mean, it just seems like it would be just like every day is almost like a blank sheet of paper in your place. You're moving, you're trying to launch something. You're actually going to launch something.
Yeah.
Where a lot of people work on a product, they'll work on code. You can feel it, it's going to go somewhere.
Yeah.
But there's like a dream happening there every day. How do you keep that alive every day where
Yeah.
people don't get in this mode of, oh, God, is this ever going to really happen?
Yeah, no, absolutely.
How do you keep that going?
It's new to me because I come from a world of startups where you iterate and you get your product out to users and you get feedback and you try to get those cycles to be as short as possible, right? And so I find it jarring personally, but I think many of the people we hire, they actually look at this program and think it moves incredibly fast. Mm-hmm. We move faster than most companies in aerospace, with a few small exceptions of places like SpaceX maybe, where they've gotten good at this. But if you're an aerospace engineer and you're used to working on airplane after airplane, and you come to Boom, I think you find it energizing because they're not expecting that sort of rapid delivery, feedback cycle. But that doesn't mean that's okay. I think it's just a calibration thing. But
does it take the Elon Musks of the world to do this, the Richard Bransons of the world, the Jeff Bezos of the world, your leader, your CEO, people like you?
Yeah.
Because why can't the big airline, why can't they just do this as a side project?
Right. Does it take? So I'll answer the first part first, which is maybe, because I don't. Blake would be angry at me if I told him that he's up there with Elon Musk or whoever, because he's a very humble guy. But I think it does take a sort of visionary person, and he is that kind of visionary CEO. But we have drawn and still draw a ton of inspiration from places like SpaceX, where they've basically proven that you can tackle something really hard that involves a lot of capital, that's hardware, and that it's possible to do, and that you can get the funding for it, and that it's worthwhile doing. I think if those companies hadn't sort of been shown some success first, this company never would have been started, and certainly never would have been funded. So I think, yeah, I mean that's the I'll stop there. But,
Yeah. I've got just a few minutes
Yeah.
left. I'm sorry. I'll take some questions from the audience. Sorry, I could
Sure.
just keep talking to you about all this. Throw some questions out, everybody. Sorry about that. Just a few minutes left.
Oh, hi, I'm Ben. I'm a producer in the film team, and I had two questions. So you said the video said all the seats are both aisle and window, so it's like
Mm-hmm.
So I was wondering
single
if that's necessary for some kind of engineering reason, or if that was a decision for the experience of the customers.
Right.
And my second question was
go
just how much is sort of your target price point for a flight, say from New York to London,
Right.
when this happens?
Yeah, sure. So the first question, it basically comes down to an engineering problem of the diameter of cabin that you can use. So when you're traveling at supersonic speeds, the drag that the airplane experiences is proportional to the cross-sectional area of the airplane.
Of course it is. Yeah. We all know
Of course. So,
that. We all know that.
needless to say, it's a bit more complicated than that, but it is.
I mean,
that's-
everyone
that's
knows
an
that.
idea.
You could start there. Go ahead.
Yeah, so so the fuselage diameter matters a ton, and even if you wanted to do, say, 2 and 1 or something, some other configuration, at least in our sort of airplane size that we're looking at, it's not really feasible. So that leads you to single aisle, which also happens to be great for the customer. So it's a kind of happy answer all around. And then price point, we are targeting parity with business class fares today. So, and that's actually really important because when we go out to airlines and we're trying to tell them your customers are going to want to fly on this instead of the Dreamliner, it's nice to not have a conversation about the price elasticity of switching due to speed, because no one knows the answer to that. I mean, who knows? We think it's actually a ton of people will want to pay more to fly to get there faster. I think that's fairly obvious, but how much more? And all those questions kind of come in. So we've designed the airplane's economics such that if we can meet parity with business class prices, then it makes it a very straightforward question. Would you like to get there twice as fast? And most people at that point say yes.
Yeah,
So.
of course. Another question? Can't see.
Yeah.
Anyone? There we go. Justin McGuire.
Hi, I'm Justin. Nice to meet you. I'm just curious if this is still primarily for overseas or if you've been working to deal with the overland sonic boom issues.
Right. So we built the whole business case around only over water routes because the regulatory risk involved in assuming that you could get the overland ban reversed is pretty critical. I mean, it would be hard to get funding if you made those assumptions. That said, we like to say if you could get from San Francisco to Tokyo faster than you can get from San Francisco to DC, maybe there's some appetite for doing something about that. Our airplane will be quite a lot quieter than Concorde because it's smaller, mainly, but also just has a bunch of new engine technology and the aerodynamics that make it quieter. So there's a lot of uncertainty around overland supersonics and what is acceptable for the public as far as a sonic boom impact, but it doesn't matter to our business case directly, so that's a good thing.
Back up here.
It's on. It is on. Okay. Hi, Tim Shiner. Your message conveyed a bunch about the value of bringing people together and stuff like that. And so then I was wondering, like, in terms of an analogy to Tesla, where like they started out with the sports car, and now they're trying to eventually get to a more affordable vehicle.
Yeah.
And I wondered whether that was actually part of your vision, like you actually think this kind of supersonic travel could get cost-effective for non-business travelers, or
Yeah.
what is the thoughts about that?
Yeah, absolutely. It's definitely where we want to head as a company, sort of from a vision and mission standpoint. The first airplane, yeah, it's, like I said, the minimally viable supersonic airplane. I mean, it's the one that makes the most sense, the least amount of new technology, least amount of regulatory risk as far as certification. But if you look down the road at a subsequent model, and you make some assumptions about the fact that if you come to market with a supersonic airplane, that increases the demand for travel globally. The next airplane could be bigger. Bigger is actually good from an efficiency standpoint, so that gets costs down. And of course, as costs come down, that creates sort of a flywheel effect where demand goes up as well. And then some other things too, is as you go faster, utilization of the airplane is better, and things like crew time and food service and all kinds of other things are proportionally reduced. And so, yeah, I mean, we very much see a future where you can get this to sort of economy class type prices, but it's a generation or maybe two down the road, depending on what happens. But it's a ways out. Yeah.
One last question, right here.
Hi, Arij Bazari. I just have a quick question. I worked at British Aerospace Engineering for a while, and I know that there's a lot of legal and political stuff that you have to work through and lobby for any technology like this. I'm just curious to hear more about the kind of stuff that you guys had to work for.
Sure. I think there's two camps there. One is the certification side, which is really about engineering. That's working with the FAA and ICAO to develop a plan for how you're going to certify your airplane, and then follow the many years process through that to get it certified. That's the blueprint for that is pretty laid out. It's a known problem. On the other side of the company, when you think about things like airport noise and overland supersonic corridors and things like that, we have a policy guy in DC and a lobbyist as well who sort of work on our behalf and make the case that it's worth looking at supersonic a little differently than subsonic airplanes. It's early to know exactly what's going to happen there, but there's some appetite to try to allow this new kind of innovation to happen here in the U.S. with a private company. So we'll see.
That's excellent. As someone who flies all the time and loves my family and wants to get home, I wish you the best of luck, and please, for the love of God, get this going as soon as humanly possible.
Yeah.
And thanks so much for coming and sharing your story with us today.
Thank
Thanks
you.
a lot.